Karibu tena, karibu sana. And the lesson today, I'm moving on to integration, an interesting topic under the fourth syllabus. And mostly integration becomes easy to understand if at all you have gone through what we call the differential calculus. Now, I'll take you through a short recap of differentiation, so that when you come and build on those differentiation, it will be easier for you to understand those terms and also method that I'll be using to integrate different functions. Recall that differentiation of a function, let's say for example, y equals to x cubed plus x squared plus 7 is given by 3x squared plus 2x. To understand this more, remember we said the power is taken back, then multiplied by the coefficient of that variable, then we minus 1 from the power. By so doing that one, we end up with 3x squared. Then we also take 2 back, then we minus 1 from the power, then we get 2x. But also recall that differential of a constant is always 0. Now notice that the constant part goes to 0. That is, any function that is given and it's a constant, for example, y equals to k, where k is a constant, then the differential of that function is 0. Now, similarly, if the power of a given variable is 1, then we'll drop that variable. For instance, if y equals to 2x, then it's not hard to note that dy dx is 2. Or for y equals to x, it's also easy to see that dy dx equals to 1. I've demonstrated there where I've said if y equals to 2x, remember x is to power 1, then dy dx equals to 1 multiplied by 2, then x 1 minus 1. Remember, we minus 1 from the power, right, together. So this one gives us 2 x raised to 0. And any number raised to 0 from indices, you know that number goes to 1. So 1 times 2 is actually 2. That's why we are saying if y equals to 2x, then dy dx is 2. Now, this process of finding any function from the gradient function is called integration. Now, integration can also be defined as the reverse of differentiation. The reverse of differentiation. So what you are doing, the process you are following to differentiate a function, we are going to do the reverse of it so that we can get the function that was differentiated to get that particular gradient function. Now, for instance, if dy dx equals to 2x squared plus x plus 7, then it's easy to note that y equals to 2x squared, add 1 to the power, and then divide with the resulting power. So it will be x squared plus 2 over 2 plus 1. Now plus, remember x is to power 1, so add 1 to that power, we get 1 plus 1 over 1 plus 1, then plus 7. Remember 7 is actually 7x raised to 0, then plus 1 over 0 plus 1, which gives you 7x. Or remember we dropped a variable when it was power 1, therefore we're introducing that variable back, and then plus c. This c stands for the constant that went to 0, because from differentiation side we said that differential of a constant was 0. So we'll put plus c to stand for that constant that went to 0. Now, if you simplify that expression, then we end up with y equals to 2 over 3x cubed plus a half x squared plus 7x plus a constant c. Notice that that constant c is referred to as an arbitrary constant, and the function obtained is called the general solution. Now, if we are provided with more information, sometimes we refer to it as the initial conditions, then it's easy now to find the value of that arbitrary constant. For example, the equation I've labeled 1, if we assume that that curve passes through point 0, 1, then it's easy to find the value of C. And this one is going to be done by this. We are going to substitute the values of X and Y so that we end up with C. So where there's Y, we put 0, and where there's X, we put 0. And by so doing that one, we realize that C equals to 0. And therefore, we substitute the value of C to that general solution to get now what we call the particular solution. Once we know the value of C, then the equation now moves from general solution now to particular solution. Now we are going to see now our particular solution now becomes to y equals to 2 over 3 x cubed plus a half x squared plus 7x. Are you together? Because already we know that C is 0. Now, you realize too that integration has a notation, and mostly we have two types of integration. The first one we refer to it as indefinite integral, and this indefinite integral actually has no limit. Most of the time, integration is noted by an extended s. Now, indefinite integral is noted by that extended s with y dx. And when you're integrating an indefinite integral, you have to introduce a constant c. Remember this, an indefinite integral results to a function. Together? We're also going to realize that definite integral has limits, for example, from a to b, integral of y dx. And then you integrate that function, and then you substitute the limits, starting with the upper limit, then you minus the 2. The difference you get is actually a numerical value. That's why we are saying for indefinite integral, we end up with a function, which is a general solution. But for definite integral, we end up with a numerical value. I'm giving an example. For example, you are told to integrate a function x squared plus 2 dx. Remember this one, we said you add 1 to the power and you divide by the resulting power. So this one is now going to be y equals to x cubed over 3 plus 2x plus c. Notice that you are getting a general solution. But when you move to the second one, notice that you have an integral from 0 to 2 of 2x plus 3 dx. Now for this one, we are going to integrate the function inside the bracket, and you're getting it as x squared and then plus 3x, and then the limits given are from 0 to 2. The lower one is given as 0, which is the lower limit. The upper one, we refer to it as the upper limit. So we'll start with the upper limit 2, and then you substitute into x, where 2 squared goes to 4, plus 3 into 2, which goes to 6, minus, you now substitute the lower limit, 0 into x squared and 0 into 3, which you get 0 plus 0, and here you get 4 plus 6. Now 4 plus 6 is 10, and 0 plus 0 is 0. Then you subtract the 2, you get 10. So that definite integral gives you the value as 10. So you realize it's a numerical value. Now integration actually can be applied. We can actually approach integration by this rule, that if you're given dy dx equals to axn, then y equals to add 1 to the power to be n plus 1, and then divide by the resulting power, and then add a constant c, which for this case we refer to it as an arbitrary constant. I believe that lesson has enabled you to have an insight on how to integrate different functions. Now, my next lesson will be on the application of integration, and I will consider majorly on the area under the curve using integration approach, and also kinematics that will be under the application of integration. So to get my videos and more lessons in future, subscribe to that YouTube channel so that anytime I upload a video, you will be able to get a notification. Thank you, and may God bless you up to the next lesson. Thank you.